Welcome to IDA's video channel. In this video, I will show you how to run analysis with pump. In a previous video, I covered how to run a system curve analysis, and based on the system curves, I found the pump suitable for this pipe network. But you might also be supplied with a pump curve from someone else, so maybe you didn't need to run a system curve analysis. So for this exercise, I used the drawing where I didn't run any analysis yet, and I want to show you how to proceed with the analysis as well. You can also continue in the drawing from the previous exercise. It will be just a little bit easier because you already modified some of the parameters, you inserted the junction where you want your pump and so on. First of all, let's go to long section. And here we have a reservoir, which is infinite source of water. Then we want a pump, and we want to pump the water into this tank. If I scroll to the right hand side, this is the tank. So let's insert a pump here at the beginning. If you want to use the compact ribbon, you go to ribbon IDAS and then you go to insert structure. If you want to use an extended ribbon, you go to IDAS network edit, insert, then specify the network name, the surface. As a structure, select pump. You can type P or you can type pump and it will select pump. Let me do it again. It doesn't do it like that, so I need to press P. Select pump. Then under the pipe cover, I don't really care about it because I want to interpolate the structure depth from the current pipe slope. OK, and then I insert structure. I escape and I zoom out. This is the pump. I select the pump and I go to structure properties because I want to change its name. Currently it's called MH59. I will rename it to pump. OK. What I sometimes do as well, I rename the incoming and outgoing pipe. It will be easier later on for me to assign the correct outgoing pipe to pump. Select the incoming pipe and go to pipe properties. And it is called P1. I can call it P1 in. And then for the outgoing pipe, I select pipe and I go to pipe properties. And then I call it P1 out. Okay, so I have an infinite source of water, which is a reservoir. Then I have a pump and I have pipes renamed based on a location. And then I can go to pipe manager if you use a compact ribbon. If you use extended ribbon, you can use manage and analyze. If you went through the previous exercises, you know how to set the network and how to work with the mappings and all that. You also know a little bit about the hydraulics and all that. So I would really suggest that you go through those videos so you are familiar with the basics. I will cover a little bit here as well, but not much. I won't go to that detail. Anyway, so we have a network here and we need to assign the properties to structures and pipes. Let's go to structures, then water resources, reservoir. Under the reservoir, this is our reservoir, which has a surface elevation, inward elevation, depth below surface, and then we need to define water depth. I want to use 2 meters of water depth. So the total head is inward elevation plus the water depth. There's also an option to specify the head pattern. The patterns can be defined under library patterns. Let me go back to water source. Then I go to tanks. And for the tank, I can specify whether the connected pipes are open or closed. I want them to be open. I can also specify whether I want the tank to be cylindrical, box, or other. If I define the cylindrical shape, then I can specify the radius or diameter, which is here. If I use a box, then I need to define the tank area. And if I use other, then I can specify the volume curve. I will keep it simple, so I will use a cylindrical. Then it shows me the inward elevation, height above surface. There is also an option to specify the inlet position. It can be not applicable, which means the pipe is connected at the bottom of the tank, which means the depth in a tank will have an impact on a system resistance, because the more water we will have in a tank, the higher the resistance. Then you can also specify the top, and you can simulate atmospheric inflow, or you can say it is at the bottom. If you use a bottom or top, you can specify the inlet elevation, but for now it's not applicable. Then it is important to specify the initial water depth at the beginning of the analysis. I will use 1 meter, but you can use any suitable value. If it shows you the exclamation mark, it might be because there's an issue. For example, in this case, initial water depth is above maximum level. So I need to fix those other columns. Minimum water depth, I will use a 0.1. And then maximum water depth, let's say 4 meters. As a tank diameter, if I'm not interested into tank sizing, if I just want to run the analysis and see the flow through the system, I often use a very large tank because I don't want the tank to get full during the analysis. So I will use 1,000 meters. And as I said, those other settings are if you use other shape. Then I go to pumps. We have a pump, and very important, and this is something users often forget, to set the outgoing pipe. So go and change the outgoing pipe to P1 out. That's very important because, as I said, we get a lot of drawings from the users. They say their analysis doesn't work because they forget about the outgoing pipe, because this will set the pump direction. In IDAS, the pump is structure, but in the analytical engine that we use, IPANET engine, the pump is modeled as a conduit. Then we have surface elevation, invert elevation, depth below surface, and then we need to assign pump curve or power. If you want to use a power, you must set the pump curve to none, and then you specify the power. If you want to use a pump curve, then you must define the pump curve. And let's do that. I go to Library, Curves, and then I create a new curve. I will call it Pump. Then as a type, I will select Pump, and number of values, I will use 3. I will keep it very simple. So based on a system curve, I found out the pump, and I need to define the values here. So for the flow, I got the values 10, 24, 32. And as you can see, the flow must be increasing and the head is decreasing. So I got a value 60, 34, and 10. So this is my pump curve. I go to Structures, Pumps, and I assign pump curve to pump. I don't need to define the power, but I need to specify the speed multiplier, and I want to use 1. Of course, if you want, you can change it. There's also an option to use a speed pattern as well. There are some other settings for the energy price and efficiency curve and all that, but I will skip it for now. And let's go to conduits. Under conduits, you can see some exclamation marks, and there's a roughness coefficient is too small. So I need to assign roughness coefficient. I go to hydraulic parameters, and as a head loss formula, currently I'm using Darcy-Weisbach. There's also an option to use a Shazy-Manning and Hazer-Williams, but Darcy-Weisbach is probably the most accurate from those 3. If you want to know what are the typical values used for this head loss formula, you can go to Documents. You can press Ctrl F for search, find. You can also use this button. And then you can type Darcy, and it will find the table with the typical values. Let me scroll down a bit. And here is the table. This table is very similar to that table which is in an IPANET manual, which I showed in another video how to open it and where you can get more details. Darcy-Weisbach in millimeters, the value is here for plastic, and I'm using HDPE 0.0015. So let's use that. By the way, I will stop here because we also have a minor losses here, which we will assign as well. So I'm going to Conduits, and then I want to assign roughness coefficient. I select this corner, and then it selects all the pipes. I can also use a shift if I want to, but this is quicker. Then I right click anywhere, roughness coefficient 0.0015. Then if I want to, I can also assign the minor losses. This might be a little bit confusing because the minor losses are property of the fittings, but why it is under the pipes? Because IPANET engine uses those minor losses as an additional friction to the pipes. If I go to Help again, and if I scroll down here, I will try to zoom in. you can see that this is a formula for minor losses and this is a coefficient. Here are the values, for example, 45 degree elbow 0.4, then 90 degrees elbow, I believe these are 0.9 and all that. So you can use these coefficients. Here are some suggestions, like if you know what's the flow direction, you can specify the minor loss to the outgoing pipe or you distribute it and so on. So there are some suggestions, but again, you need an engineering judgment to assign the values correctly. But let me show you, for example, if I go to conduits, and then if I zoom to this corner, this is a 90 degree, let's say I want to use 0.4, and I know the flow direction is in this direction, so I will assign it to P2. If I scroll to the left, I will select P2. By the way, you can use a filters, and you can select it from here, or you can use a text filter, where you can say contains, I can say P2, apply, and it finds all of them that contains P2, and I can assign minor loss of 0.4, for example. If I want to remove, I can clear the filter and it's back. So this is how you can work with the filters and with the minor losses. Or some users, they prefer using a very low value for each and every pipe, let's say 0.1. So again, a little bit of engineering judgment is needed here. And you can also read through the manual if you want a little bit more details. Let's go to structures and let's go to junctions and bands. Here you can check the horizontal, vertical, combined and allocated bands if you want to use these values to assign the correct minor loss to the pipe. But the reason I came here is that there is an exclamation mark at the name, and it says the name is limited to 15 characters. So I would always suggest fix those issues before you run the analysis. It will run, but sometimes it causes the problems if the name of the object, either pipe or structure, is longer than 15 characters. So this is a HB1 ABCD. So let's fix it first. I go to ribbon home and I want to click on update because I already did some changes in a pipe manager. So I want to update these changes or save these changes. I don't need to update the results because I didn't run the analysis yet, but I want to update geometry changes or anything else. Then I go to find command. I can either go to compact ribbon, find part, or I can go to edit network, find part. Then I want to use a HB1 and I can go to plan or profile, doesn't really matter. And I will change the name. So I go to structure properties and then I remove those other characters. I left it there for purpose because I often get drawings that do have this issue. It looks better now, and I'm going to either IDAS Pipe Manager or Manage and Analyze. If I go back to Structures, Junctions, Bands, there is no longer exclamation mark. I can also go to Time and Energy and I can set the analysis duration if I want to run it for 24 hours or longer period or shorter period. So I can change the values here. And I'm ready to run the analysis. I can go to Analysis and I can use command Analyze because the peak flow analysis, as I mentioned in the previous videos, is used for water reticulation network. If I want to run the analysis, peak flow analysis where I combine house connections with a specific fire hydrants. And for that we use a patterns, and because to develop patterns and assign them to the correct structures is time consuming, IDAS can do it automatically for you. But in this case we're running normal analysis. And if you want, you can also right click and use Analyze. I think here there might be Analyze as well, but not probably here. If you right click on this graph, it doesn't show you Analyze. But most of the time under the right click, you can find Analyze. So let's analyze. It says warning, let me go to report, and under the report, or I can go to report, it shows me the report. Again, if you look at my previous videos, I explain a little bit more how to, for example, display hydraulic status and all that. And there are no errors, everything worked well. And here I can see the results. And for example, this pump can deliver 24.44 liters per second. The velocity is 2.49. If I want, I can go to graphs and I can sort by name. And for any specific node, I can display, for example, the pressure. And this is during 24 hours. And you can see it differs. Why? Because the more water I get in a tank, the higher the system resistance. But the values are almost very the same because I have a massive tank, so the water level raises, but only just a little bit. So this is very much exaggerated. It would be flat if you display different scale. I just wanted to show you that we have those graphs available. You can export, copy if you want to. There's also an option to display other parameters. You can also go to conduits, you can display velocities, you can display flow. And if the graph shrinks like that, you can move the slider a bit and it will update. And again, there's a minor change between the values because our tank is getting full, but the discrepancy is really minor, negligible. And let's explore the plan, because in a plan, you can display the analytical model and you can say, okay, I want to display pressure. And if the pressure is above 28, I want to display value to be red. Okay. So let's say these nodes have a pressure above 28, or you can specify where the pressure is lower than a specific value. I will turn off analytical model. You can also go to profile, view, and display hydraulic and energy grade line. You can see there's a problem here. Why? We need to find out. Most probably the pipe direction method is wrong. I will zoom. I'm using left mouse button. And this is pipe P13. I go to ribbon home, update, because I want to update all the changes. I didn't update the results yet. Then I need to find the pipe P13. So I go to find part in an extended ribbon or find part in a compacted ribbon. Then I type P13 and it searches here. I can see it in a plan. I can select it and I go to pipe properties. And I can change the pipe direction method. And it must be bidirectional. For the water reticulation and bulk water pipelines, we always use bidirectional flow direction method. What if you want to change it for the entire network? You can do it. If you go to compact ribbon, you can go to water, swap direction. If you want to use extended ribbon, you go to IDAS network, direction. Then you select all the pipes and you set the flow direction method to be bidirectional. Okay. And that's it. Go to pipe manager or manage and analyze or pipe manager. Let's go to profiles and you can see it looks much better. If you want to, you can reanalyze just to make sure everything is updated. You can also go to structures, nodes, and you can display pressure. You can sort it. You can use filters if you want to. You can highlight the values in plan. For example, all the values above 22 maximum value you can highlight. And you could see that if I stop with mouse button away, here it doesn't highlight. So you must make sure that when you stop with the mouse cursor, you stop on a cell and it highlights those objects. You can export everything to Excel as well if you wish to. Any grid can be exported to Excel. And then you can go to conduits and you can display the flow and velocity here as well. You can check the values whether you like them or not. The results in this table, they are shown either for a specific time period or the maximum values. So if I come here, I can change the time period and that will have an impact on the results. But in this case, the change is very minor. So that's why you don't see any change. But if I make the tank smaller, let's do it. So I will use a 10 meters in diameter. If I run the analysis, okay. If I go to report, it will show you that there will be some issues here. You see that it cannot deliver the head because it's closed. Probably tank is closed at 4 meters. There are some issues and it's even balanced after 201. So there are some problems. Maybe, let's see if I have a result here. Maybe now if I go to structures, let's say, I go to nodes, I want to display pressure, and I can select specific time period, and I can use an arrow down, and as you can see, when I go with the arrow up and down, it changes the values. So you can display the values for a specific period, or you can display maximum values. In another video, in the video where I cover a little bit more about the analysis settings, I also cover that you can specify how you want this report to be. You can display the values for each time period, or you can specify or display the maximums, minimums, average, and all that. And that can be set under the statistics. Here I'm using no statistics now. So this is a little bit about the results. Let me go back to structures, and then I will change the tank back to 1000 meters so we get a little bit better result. Let me analyze. Okay. And then I go to conduits and I will check the flow and velocity. And the velocity is a little bit too high. Let's say I don't like this value. I would like to lower it, or I would like to see what happens if I use a bigger pipe. I can simply select all the pipes with a clicking on this corner, right click, and then I go to swap conduit size. And I will use, let's say, 160. Okay, resize at invert. So currently the value is 24.444 and 2.490. I will rerun the analysis and the value will change. As you can see, 28.226, 2.207. And I'm happy with the outcome. I can go to ribbon home, and now I want to update results to Civil 3D. So I want the flows, velocities, pressure to be written back to pipe and structure properties. And I will click on update. That will also update the pipe size. Let me zoom in here. You will see that now it is 160 pipe. And if I check the hydraulics, I get a 28.23 liters per second and 2.2 meters per second. So these are the results. What if I want to display hydraulic and energy grade lines? In some of the previous exercises, I turned them off. So go to Layer Manager if it is turned off. Go to Filters, Water, and then go to HGL, EGL, and defreeze or thaw the layer, and it should appear. If it doesn't appear, you can always go to Edit Pipe Style and just double check that under the display profile, make sure the hydraulic and energy grade lines are on. And you should also double check if the height of the profile view is sufficient. In this case, it's not. I need to modify it. So I go to Profile View Properties. Even if you set the profile view to have automatic height, somehow Civil 3D doesn't recognize the HGL and EGL. So you must adjust it manually. So I will use maximum, let's say 45 meters. Okay. And if I zoom out, this is the result. So I have a flows, velocity, hydraulic, and energy grade lines displayed in a profile view. And I can also double check pipe and structure properties. If I go to pipe properties, let me go there, pipe properties, and I scroll down, there are DEV properties, and I can see that there is a design, flow, and design velocity. Here there are some other properties as well written back. And if I go to structure properties, let's say I go to this air valve, I go to structure properties, part properties, you can see that there will be some properties such as angles. There might be also pressure and HGL. So these are properties written back from the pipe manager into pipes and structures.